probably the primary agenda going to be general landscape, and then what are the use cases, and then how the trends are going, right? I'm going to cover that. And similarly, small patterns, like if you are going to adopt LLM to that your application, what kind of a path you should take, what are the patterns you take. Then finally, small demo, if if time permits, as well as that the demo guard allows, we'll have a small demo. And then we are going to talk about a little bit in-depth concept, the fine-tuning and inference. In fact, it is slightly, I would say, it's slightly related to the previous session where how the GPU is the parallelization, right? Even here, this fine-tuning and inference is very tight correlation with that GPU utilization and the hardware, right? I think this is a question I'm not going to say. If mostly you will know the answer, right? Typically, if you ask a question, you'll get the answer like this from one of the model itself. It's primarily, it's going to create basically the whole idea of the generative AI is the model going to generate a content uniquely based on that what it learned during the training time. So it can be like anything. You can ask about how do I make a coriander chutney. It's going to give you its own recipe of what it learned from that memory, right? And because of this, the entire explosion of this generative AI, so many industries are today started leveraging it. I think I'm working with a lot of customers. Many customers today, the FOMO, they called it FOMO, fear of missing out, right? Everyone wants to do something with the generative AI. Even the same thing can be done with the regular stuff itself, but still we want to do with the generative AI. But there is this, even though it may be a hype, but still it has some unique benefits. Like for example, some of the use cases, this can do really better job. Like for example, the chatbots. I think that's the most common thing. In fact, does anyone do not know about ChatGPT? That's the one, right? It's the fastest adoption. Even actually, I don't use Instagram or anything, but I use ChatGPT, right? It's like that. So even people do not use the social media, use ChatGPT. That famous it is, and the primarily why it's amused people is because of the nature it answers the question. In fact, sometimes it's scary, right? It answers like there's another person sitting opposite and talking to it. It's not like the chatbot, right? Just before the ChatGPT, this generative AI, we still had automated chatbots like using programs that we clearly people know. I mean, the moment we saw when you go to the bank sites, there is a ask, Deva, ask, etc. Some will come. We know that that's a dummy chatbot or it's just a program chatbot. But today, if you make a chatbot using generative AI, it's very difficult for you to tell whether that person is real person or a model actually. So that's how it is. That's why it's kind of a lot of people made think about it, right? So similarly in that entire customer experience area, this can give you better results. And the summarization, the simple questions, like even today, I mean in our organization, even I'm part of a role called solution architecture role. So what we do is customers ask a problem, hey, how do I do it in AWS? How do I solve it? So what we do is we search in Google, we'll find the article, we read, and nicely we go present it. That's what we do it, right? Now the entire job is not needed, okay? It can be done by this generative AI. It can do a nice search itself, and then it can give a very good results, better than us. We may miss out some details because we have only less search, right? That can do a better, consume more big book, and then can give a better answers. So what does it mean is it actually boosts your productivity of the employees, right? The applications today, a lot of applications develop in that nature. Many internal organization, internal applications, they are actually making it better with this generative AI. And these two areas, the mainly the creative content writing, I think we should have, I think anyone use Midjourneys, the stable diffusions, they produce images like anything. I mean, even there is in India, there is a one news thing, there was a the generative AI model generated a female character, reads news. It's as good as like, the real person. Yeah, we can make out, still it has not reached that level of producing a real person, but still it was really, better. And the business operations, again, completely that the analyzing, anomaly detections. Earlier, these things used to be a very hard problem to solve. But now with the, this generative AI, this LLMs, we could easily solve it, right? These are some of the use cases. The reason I highlighted that was because where we can use these models and then how do we develop applications, right? This is what that industry currently using it. And now we talked about that, what's the use case, generative AI, how does it work, right? Under the hood, primarily how the generative AI works is because of these foundation models. The reason it's called foundation model is it trained with a vast amount of unstructured data. Like this till probably whatever the years, decades, internet is online. All the data, they crawled it, they curated it, the entire data they load. Basically, it looks like they made a person with a freshly cloned person, sit them, read all the entire internet data. Now that person is a foundation model. That's how it is, right? So it learned a lot of patterns, a lot of complex structure on the language, a lot of information, the relationships, everything it learned, and then it created something called emerging capability. It's a paper, you can read about it, why the foundation models or large language models behave the way it is. It's called its emerging capability. Till the time, the machine learning model was dumb, okay? So when you train, whatever you train, if you answer it, it will work with the trained data. So once you keep on increasing the data quantity, as well as make the model size bigger and bigger, right? There's a point, tipping point or a kind of a point emerging capability. Suddenly, the model started behaving like, I don't say like a human, started behaving like a better answers. Like they started identifying the patterns better, started generating the answers better. That's when this entire curve, I mean, there is a curve, I didn't put it. It's a nice curve, it explains. Till the time, it's like a normal dumb model. After a certain point of them, it started becoming a foundation model. So that's how, if you see the traditional models, anything you want to do, I think how many of you already work with something, some or other thing, machine learning? I think everyone in the day-to-day, you use machine learning as a user, but who creates applications in this room using machine learning? I think a lot of people, right? So you already know, if you want to create a one model, if I'm going to make the model to answer my questions related about latest movies status, right? What we'll do is, we will basically train a lot of data with the movie reviews, and then that model will behave better. Similarly, for every specific task, I want to create a model only to summarize my emails. I'll create a lot of task-specific data to do it. That's how the traditional ML is there. But with this LLM, because of the emerging capabilities, you train once with a large model, it can do any task. You give me a task, just say the task, I'll do it. That's how it has become now, right? That's the main why it's creating a lot of buzz, right? I don't have to spend a lot of time correcting data, train the individual models. I'll pick up a right foundation model. Today you pick up, tomorrow you can implement your application. You don't have to spend a lot of time in the training and etc. Right? That's how the landscape is. So now, we just talked about the general foundation model, generative AI theory, right? There is a multiple types of foundation models itself. The one which I'm going to primarily focus on, the first one, the text to text, or we call it as a large language model, where you give a text input, you get a text output. I mean, the input can be anything. Summarize this paragraph, or generate a nice essay for me, create this report for me. All those things will be text, and the output will be in the text, right? That's the model. There is a second model, we call it as a embeddings model, text to embeddings. You give a text saying that, hey, this is Arun Balaji, so and so, like that. You give a 10 paragraph, it will give you a embeddings, like it's kind of represent me in numbers. So that tomorrow, if someone else has the same qualities as mine, it can easily search. So it will be very useful in semantic search. Like this is when long times Amazon under the hood, they use e-commerce sites. When you search, show me probably like mobile holder, so it can know what are the different items belong to a similar category. So they do a semantic search, which is kind of this text to embeddings. The third one is we call it as a multi-model image to, like for example, I'll give an image, generate a similar image, or I'll give a prompt saying that generate me an image of very similar to Shah Rukh Khan, so it can generate another image of Shah Rukh Khan, or make me look like a Shah Rukh Khan, it can do that actually, right? So this is called multi-model, or we call it as image to text to image, or diffusion models. These are all comes under this category. These are the three different categories for based on the application we can choose. But today I'm going to cover more on this the foundation model, language models. So as I said, right, this is a language model. How I can to use it. Just before you use it, you need to know few pointers about this. Some of the important what they can do well. Where is the limitations, right? Some of the superpowers are, as I multiple times mentioned, they can really understand the complex content, aggregate and summarize. They can easily generate new contents for you. And even I don't know anything about banking, I can give a very good advice on financial, how to plan for financial. By the way, the model I'll come to the next slide, and we can easily make the model produce better outputs. For example, the model, when you ask the first question, what is a SageMaker? It's a service in Amazon. What is SageMaker? So it can give you a bad answer, but you can really make the model answer better by giving some nudges, right? So like when you are a kid, right? If you don't answer well, if you get a stick in hand, you'll answer better. By the way, nowadays no one beats kids, but when you used to be kids, it happened, right? So like that, you can give a better prompt, then the model can answer you better. It's just that without stick. So and further, we have options to tune the models and then tune the feedback. This is some of the superpowers, right? If you come to the limitations, as I told you, right, if you go to ask the model, how can I plan my finance better? It can give you the answer. By the way, it can give you the answer, some hallucinated answer. Don't follow that, okay? You may miserably fail, right? That's the problem with this model. They can confidently give you the wrong answer, by the way. It can tell you that, okay, you do this 10 things, you'll become a millionaire. Probably it will be the opposite, okay? That's the problem with this model. These are like trained on large data set. You never control the data set. So that's one of the problem. And similar thing is, sometimes very specific. For example, in the previous slide, we talked a lot about GPU parallelism, etc. If I go very specific domain data, they may not be able to answer very well, right? Because they don't have the specific domain data. And similarly, these are very expensive ones. We'll see more on that, right? How expensive it is, right? So now with this, since you know these limitations, how can I design my application? What is I know it's very cool. It's producing very good results. This is my use case, and I know the limitations. Now, if I want to build an application, what kind of approach I should be taking it. You see, this is called snowball effect. It's not that either option 1 or 2 or 3 or nothing like that. You could use all the 5 together, or you can do in one step, you can stop it, right? The idea here is basically you have to choose the very first step would be choose the right model. There are many open source models available. I'm going to cover a small slide. Many open source models available. You can choose one which is very close to your data set or latest data set, or even if you give you a good result, right? You need to evaluate and choose the right LLM. That's the very first step on any application building. The second step is you can try to ask a question, and then you can see that whether it's solving my task. If it's doing good, it's very, very good. In case if it's not doing it, there are approaches called in-context learning, prompt engineering techniques, where we can make the model do better job for you. So I'm not going to go deep because we don't have enough time to do that, but I have few slides to cover it up. But the whole idea is make that, as I told the stick, right? You can have many options to make the same chosen model perform better for you. That's the second step. These two are very easy to do. You don't have to do. You can do today. Next 1 week, you can make your application. If you have front end and everything ready, you can make it up and running. Now, what if I don't find a good results with this? What is the further choices? Then we have something called LLM agents. This will be, in context with, or I'd say in conjunction with your chosen model, they can do additional tasks to make your model perform better. I'll give you a few pointers on it. So this will help you. Maybe you will say, can you tell me about something like, probably how do I design my kitchen? Now, this model may not know the answer. With the LLM agents, the agents know, okay, the model doesn't know the answer. Let me go search the internet, get the answer to you, and then I'll present to you. So this conjunction with this kind of additional automations, you can give a better results. So that's what called as LLM agent. So this is, if you see, right, step 1, 2, 3, till 3, you may get results. But after 3, now I'm in a very, very specific domain, and I want to apply, specific domain data. That's when we have to go with the fine tuning of the model. Same model, I'll give additional data to train, and then I will use the model for the final thing. The final thing will be like, this is when that all the AI companies like OpenAI, all the large companies train the model from scratch. If you want, you can create a new foundation model until if you have some 10 million to 100 million lying in your packet, we can train this complete full model. That's how the cost to train, right? So as I told you, there is a very different factors to consider, the foundation models, starting from the context length all the way from the licensing conditions, specific task specific one. There are certain models, foundation model created for specific domains. We could also, there are architectures, encoder, decoder architecture. Depends upon that, we can choose. There are model sizes. If you have a budget is very strict constraint, go for a smaller model with a fine-tune option, so that you can save cost there, right? And some of the key open source models, I would say, probably, I don't know if you have heard these terminologies, definitely Llama 2, Wizard LM, Falcon, MPT, these are all like, some of the models. Llama 2 from Meta, Wizard LM is fine-tuned Llama 2, Falcon is again from TAI, is one of the UAE company, and then Mistral is the latest kid in the block. It's just 2-3 weeks old. I'm working in this domain for the last 6 months. Within 6 months, we have seen so many things happening. This is just list. It's going to, further, I would say grow, right? So till now, we have seen that entire pattern and approach, right? I'm going to talk about a little bit of the prompting, that how do we going to get the better output, right? So the very simple thing would be ask a question. What is LLM? It's going to give me the answer, right? Simple question. That's a simple prompting. All you do is just ask. I'll give answer. Maybe you may not get a good answer. The second approach will be, we call it as in-context learning. You give me example, okay? You say, when you ask what is LLM, please answer in terms of, as a teacher, you need to answer. Like you give an example, okay, what is LLM? You should give us a definition. LLM means this. You give 3 examples, then ask a similar question. Then model will understand those 3 answers. We call it as in-context learning. Then it will give a better answer for what was the question you asked. This is called in-context learning or a few-shot learning. This is a second approach. Then there is another thing called chain of thought. See, our humans are very good in reasoning. When you ask some question, we will not immediately answer. We will process it. Okay, fine. He is asking, how do I travel to Silk Board in the evening 6 o'clock? We'll immediately answer, don't travel now because of too much traffic. Because we applied reasoning. Right now, there's too much traffic. Better you leave 8 o'clock, we'll reach, right? How we did, we know we apply the reasoning. Same way, if you want the model to apply the reasoning, we can give a specific steps. Okay, step 1 you do this, step 2 you do this, step 3 this. Then the model also will try to do the same thing. Okay. And the final thing is on the React prompting. This is again combined with the LLM agents. The previous one is a static reasoning. This will be the dynamic reasoning. Okay, well, step 1, when I do this, it will search in the Google Map at this time what's the traffic. Then based on the traffic condition, it will do a step 2. So previously, the chain of thought is nothing but a static reasoning. You already inputted that this is what you need to do 1, 2, 3. Here, the reasoning steps vary based on the dynamic inputs from the external sources. So this is what called react, reasoning and acting, right? And these are some of the I would say like, prompting techniques where we can make the model perform better for you, the chosen model. You don't have to do any customization. And this is RAG is another approach where what you do is you keep all of your domain data, context information in a database. When you ask a question, we'll go search in the database, relevant information to the question. It may be articles. And then combine this, give it to the model. Hey, this is the context. This is the question. Now you answer within the context. This is called retrieval augmented generative models approach. So basically in this approach, I make the model don't think to yourself. You answer based on the context given. How does the context come? Context comes from the predetermined database where we maintain all of our corpus. Maybe our entire company's information will maintain it. When I ask a question, you go fetch the relevant paragraph, then you answer nicely. It's like as a kind of a do as a generative thing, right? And another part is these are some of the tools and frameworks which commonly used in developing these LLMs with applications. Some of them are LangChain. I don't know. This is one of the first one. I won't say first one. One of the famous one where many people adopted because OpenAI made them as a de facto. So because of that, people easily not adopted it. Similarly, there is a Llama index. It's upcoming. There's a fast chat. These are some of the orchestrators. We can use it to build your applications easily using these LLMs. And the vector database, just we talked about the RAGs, right? Some of the vector databases are like the Postgres has a PG vector, Quadrant is based on Rust, and then again opensearch has its own vector plugins, right? So these are some of the things. So I would say since the time is very late, we'll quickly, I'll give it to Asta. She can continue on the fine-tuning approaches. If time permits, we'll do the demo. Questions we'll take in the last if time permits, otherwise we can take it outside.
Hey, thanks Arun. Quick audio check, am I audible to all of you? Yes. Okay, so let me start by saying what an amazing time to be alive in. That we have these language models which are basically nothing but some kind of mathematical equations, and they're able to capture our human imagination almost perfectly. The two exciting things that right now I feel is the new normal that we are living in, the scale of data plus the model sizes plus the compute resources that we are using in our production. Earlier we used to think these are just research projects, but now we are able to use them in application. It's wonderful. And second, finally we are able to use natural language as an interface to different complex technologies. That has always been the dream. As Andrew Karpathy said, English is now the new hottest programming language. With that, let me come to the presentation. So when you think about it, there are significant advantages of using pre-trained model or the base model that these companies make it open source. The advantages are your computational resources. You use the model, you use the state of the model as it is without having to train them from scratch. But you're all excited when you see a model in Hugging Face and you start deploying them, and the results are really cool. But when you use that in your applications with your data and tasks, suddenly the results don't seem that well. What is really happening is your model is that model is not seeing the data that you require. So there exists a case where you need to fine-tune the model. So let's first define what is fine-tuning. Before we go further, so I think fine-tuning is nothing but extending the training of the pre-trained model with new data, which is optimized for a specific task that you are working on. So that's fine-tuning for you. Now the natural question arises, when to fine-tune? So when you see that your data is significantly different from the data that was used for pre-training data, this means the distribution of your data set is out of distribution from the pre-training data. That's when you want to think about fine-tuning, or else you have a task which is not performing fairly well with the base model itself. That means these are the two cases, or it could be combination of these two when you need the field to have a model which generally works well but performs better in your data and task. Now that you have decided that there is a case that you need to fine-tune the model, what are the different approaches that we have today? Few of these are listed here. I think the first is SFT, which is supervised fine-tuning. In terminology, it's similar to what we used to do in traditional machine learning, where we used to put a lot of X and Y's to the model, and the model used to learn the patterns from it. But it's the same here, but the goal is slightly different. With pre-training, the goal used to be like optimize. The goal used to be to complete the sentence, but with supervised fine-tuning, the goal will be to optimize the outputs, which the user seeks for. So that's what supervised fine-tuning will be. And what is the second approach actually bakes in the goodness of RLHF into SFT. So you actually will see performance getting better with RLHF. The concept here is nothing but you use human responses to score the different outputs that the model generates, and use that feedback to further improve the model. That's the second one. The third one is actually quite interesting. It's called parameter efficient fine-tuning. So as we see, the models are getting larger and larger by the time, and it's becoming infeasible to train on the consumer hardware. That means for every downstream task, you have to fine-tune that for your dataset and have a model ready. That means it's becoming very expensive when you want to store and start serving through your applications. PEFT actually addresses both the problems. So first, you only need to train certain fraction of parameters, not the entire parameters. That's how your checkpoints will be very small, and that you can apply to your complete pre-trained model. And for all the downstream tasks, you can fine-tune it, and all those generated checkpoints you can apply on a pre-trained model and use this instead. So this way you will have less cost when you are thinking of building your application. The next is open source frameworks that we generally use, and we are using these in a couple of our projects as well. This is DeepSpeed 0 as well as PyTorch FSDP. So DeepSpeed has a lot of options for training, for optimized training, distributed training, as well as inferences, and PyTorch FSDP is only for training. So here I think I kept this slide to give a quick overview of how LoRa is actually reducing your memory requirements. If you see, these 4 rows are actually the different components that is used that consumes memory when you're trying to fine-tune a model. And if you see, activations take up a lot of memory, and the grand total, if you see, LoRa for this 13B model, we saw that it was almost 1/5 the size. That means you can actually use 4 40GB GPUs or 3 40GB GPUs to train your model, which is quite efficient if you see, and the performance was also comparable. At this point, I think one needs to look at you do whatever optimization you want, then you should have an evaluation dataset and evaluate on your own. You must evaluate on your own evaluation dataset. That's the point. And this one is actually the earlier one where you saw that activations take up a lot of memory. I think here Megatron LM came up with an approach where they selectively choose when to compute activations, and with that process they were able to these were the GPUs at the end. Like the blue color is for your parameters plus optimizer, and the green one is your activation memory. You could see that red line is actually your 80GB GPU. So it's if you were not doing this optimization, it will always have been out of memory errors, but after this you can actually train that model in 80GB GPU memory. These are several optimizations that you do. Actually sum up all of them and apply them in your fine-tuning scripts. The last 3, if you see, these are the 3 ones which we predominantly use. And the DeepSpeed 0, like I said, it's a very popular DeepSpeed is a library, but 0 is actually an approach where they optimize the use of the different parameters, weights, and activations. We saw in our recent project that sharded data parallelism, which is again a technique inside the SageMaker model parallelism, combine that with PEFT, we saw a really nice performance of training time reduced drastically, and performance was also comparable. So this is something that we saw in our recent experiments, I think. And then this slide, I think this is the key for anyone who's looking for building applications with Gen AI. This is the most important piece of I think when we look at. So if you think about it, these are the key metrics that we look at. One is the time to first token, the time per output token, latency and throughput. So TTFT is nothing but how quickly your users are going to see a result after they have posted the query. That means after the query time and the first token it generates, that duration is your waiting period. And if so, low waiting period is generally ideal for all your real-time applications, and for offline sort of workloads like summarizing for large documents and etc. and stuff like that, that point it may not be relevant. But the key thing about TTFT, what it tells you about the model is how fast this model is able to process all these tokens and able to generate. So it's a key metric, not just for your application but also for your model. Now, time per output token is like this in terms of end users perspective. It's about like how they feel the speed of application is, like for every user. So you will have an application and a lot of concurrent users hitting that particular application, and they should feel like it's fast. So for example, let's say your application has 100 milliseconds per token as your TPOT. That means it's able to generate, the model is able to generate 10 tokens per second per user. And if you convert it into words per minute, that's about 450 words per minute, which is quite higher than the reading time. That means your application is really good. You did a really good job. Then latency and throughput, right? So latency is something, it's about like how it's a complete time that the model takes to generate the entire response. That's latency, and throughput is number of tokens that the model generates per second. So when you combine all of this, at any given point of time, your goal would be to have the fastest TTFT, highest throughput, and really less time per output token. That means you really want your model to generate tokens as fast as possible, but that's not possible at any given point of time. So you need to choose either latency or throughput, and in that scenario you need to apply optimization based on that. So are you building an application which is latency optimized, or are you building an application which is throughput optimized? In that case, you apply these four. These are mostly these are the four which is floating around in the literature, but quantization and parallelization we're already using in production level applications. So quantization, that's for your latency optimization. So what really happens is you have a really large model which is like FP32 or FP16 you trained, or even you used mixed precision to train the model, but it's so heavy that it cannot be loaded into the GPU memory. That's when you can use a simple approach of LLM.int8, where you can load the memory, load the model in 8 bits. That means from 16 or 32 bits, it's reduced to 8. So that's like 1/4 or 1/2. So that way you can serve the model. It becomes faster also. That's a simple one. But AWQ and GPTQ are little higher versions of that, where they quantize the weight based on a particular logic. Like for GPTQ, it's very simple. They take the weight and then they train the model such that for what kind of value it's going to give very less squared error. That's how they choose certain parameters. And for us, for our observation, what we see was what we have seen is AWQ plus VLLM was really fast for us. The latency was really good. When it comes to parallelization, we have two, which is tensor parallelism pipeline. Tensor is again similar to what we generally do in machine learning. Here as well, like, I think we do it for throughput optimization. When you want your application to generate a lot of tokens per second, you need to like apply some kind of batching technique. It could be dynamic batching or continuous batching, or even page attention batching. So from our observations in our current project that we are working, we have used VLM plus page attention. That was giving good throughput for us. I think these are the things that we have seen. And this slide actually captures all the inference related stuff. So we see like a lot of options available, like TGI, deep speed at VLLM, and there are further other options like MLC and CT translate. These are all open sourced. TGI, I think version 1 afterwards is not, but before that it is. So like in short, if I say deep speed is good for latency optimization, and VLLM is really good for throughput optimization when you use rolling batch. This was our observation from different projects. Yeah.
Cool. So basically I have to stand to close the time. So I think pretty much we are done. Any questions, you can reach out to the outside. I think we have time. Next session is going to be there. Thank you everyone. Thanks for the